Now in this example, we are going to be comparing interest earnings. It says here, suppose Bank A offers a savings account at 8% annual interest compounded quarterly. Bank B offers a savings account at 7.75% annual interest compounded monthly. And Bank C offers a savings account at 7.675% annual interest compounded continuously. If you were to open a savings account, which bank has the larger annual rate of return on your deposit? So obviously what we have here is we have these three different banks, Bank A, B, and C, and each one is offering a different interest rate and different compound periods. So we just want to know which one's going to give us the bigger rate of return on whatever money we deposit in there. So the amount of the deposit, P, is irrelevant. We just want to know which one is going to give us the bigger rate of return at the end of a year. So for A, I'm just going to put down Bank A right here. And A has an account at 8% annual interest, so its rate is at 8%. And it is compounded quarterly, so the number of compounds, pay periods, is 4. For B, I'll put B down here. Bank B offers 7.75%. So its rate is less than Bank A. However, its compounding is monthly. So we have a different number of pay periods. And then Bank C, its rate is even lower. It's 7.675%. And its compounding is continuous. So we'll just say N is equal to E. Now the future value for compound interest, that's future value that's equal to P, 1 plus R over N, N times T. Now the only portion that we're really concerned with right here is we're not concerned with the initial amount because it doesn't really matter. We just want to know the rate of return. So we have the future value that's going to be equal to 1 plus R over N. And N times T, well, if T, we're just looking for an annual rate of return. That's just once for the year. So N times 1 is simply N. So then for here, for Bank A, we have 1 plus its rate is 0.08. The number of compounds, that's 4. And raise it to the 4th power. Go into our calculator. 1 plus 0.08 divided by 4. Raise that to the 4th power. And that's approximately 1.08243216. We'll do the same for B. It has the same future value formula as A. So we'll have future value that's equal to, we're not concerned with the principal, 1 plus R over N. N times 1 is just plain old N. So this becomes 1 plus 0.0775. Number of pay periods, that's 12. Raise that to the 12th power. On our calculator, 1 plus 0.0775 divided by 12 and raise it to the 12th power. That's approximately 1.08 0.0313. And then finally for C, since this is continuous, compounding continuous, the future value, that's P times e to the r times t power. So the future value for here, again, we're not concerned with the principal. So we just have e. And then the time, that's just 1 year. So r times t, that's just r. So then this is going to be e to the 0.07675 power. So in our calculator, there's our e. Go to second e and type in 0.07675 and hit enter. 1.0797721. So now if I was to take $1,000, which bank would give me the larger rate of return? Well, if I multiply the $1,000, that would be P, to this value right here, it'll give me the larger rate of return. So I would bank with Bank A.